This is an introduction to limits. So to start, let's think about the following question. How does the function f of x equals x squared plus x minus 6 over x plus 3 behave near the point x equals 3? So to start to think about that, we could say, well, what is f of negative 3 equal to? So f of negative 3 is negative 3 squared plus negative 3 minus 6 divided by negative 3 plus 3. And we could simplify that and see that as negative 3 squared is 9, minus 3 minus 6 is minus 9 over 0. That's 0 over 0. And we already know that that is sort of bad. So that is an exclamation point saying we're worried about this. This is called an indeterminate form. Indeterminate form. And so if something is equal to 0 over 0, we don't really know what's happening. It could be going towards positive infinity. It could be going towards negative infinity. It could just be a hole, like just a little blank spot. So there are a lot of different things that could be occurring at this point. So to investigate what's happening to the function f of x around x equals negative 3, but not exactly at x equals negative 3, we'll talk about the limit of f of x as x approaches negative 3. So this is the value of f of x for points very close to x equals negative 3, but not actually at the point x equals negative 3. And this is written as the limit as x approaches negative 3. So the limit as x approaches negative 3 of f of x, that's how that phrase is pronounced, and that's how it is written notationally. We've got this arrow pointing to the right. X is approaching negative 3. And that means x is getting infinitesimally close to negative 3, but not actually arriving at negative 3. That would be equal to the limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3, just plugging in what the function is equal to. And so what could we do here? One thing that we could do is we could factor the top of that expression. So we could factor the top and find that that's equal to x plus 3 times x minus 2 in the numerator. And now, can we divide the top and the bottom by x plus 3? Well, we can. And the reason that we can is that x is not equal to negative 3. So something to note is that when x does equal negative 3, that's where we have the issue. We have an issue of this being equal to 0 over 0. Negative 3 plus 3, this would be 0. This would also be 0. But this is what happens when x is actually equal to negative 3. But the limit is telling us that x is not equal to negative 3. So as long as we are not dividing by 0, not dividing by 0, because x plus 3 is not equal to 0. X is specifically not equal to negative 3, so x plus 3 is not equal to 0. Therefore, we can write this as equal to just the limit as x approaches negative 3 of x minus 2 divided by 1. And so at that point, we can say, well, now this is a perfectly fine fraction. There's no 0 on the bottom. And so now we can just plug in as x goes towards negative 3, where does x minus 2 go? It goes towards negative 3 minus 2 over 1, which is just negative 3 minus 2 is negative 5. So the limit as x approaches negative 3 of f of x is negative 5. Once more, the reason that we could do that in the limit but not up here is that f of negative 3 gives us a 0 on the bottom. That's an indeterminate form. but the limit is specifically talking about values of x near x equals negative 3, but not equal to x equals negative 3. And we can also verify this graphically. If we graph the function f of x equals x squared plus x minus 6 over x plus 3, the function it will graph is a linear function. So when x is not equal to negative 3, x, or f of x, does just simplify to the linear function x minus 2. We just have one point where the function is not defined. So f of x not defined at x equals negative 3. But everywhere else, this function simplifies to being just equal to x minus 2, because when x is not equal to negative 3, the bottom is not equal to 0, and so we can divide by x plus 3 as long as x is not equal to negative 3. And just one more point, yes, when x is equal to negative 3, or when x is getting close to negative 3, when x is getting close to negative 3, the function value f of x is getting close to negative 5. And just to belabor the point a bit more, what we've said above is that as x gets close to negative 3, but not quite equal to negative 3, f of x gets arbitrarily close to negative 5, and we denote that by saying the limit as x goes to negative 3 of f of x is equal to negative 5. In general, if f of x is defined around a point C, but possibly not at C, then and f of x gets arbitrarily close to L as x gets close to C, we say that f of x approaches the limit L as x gets close to C, and we write it in shorthand in mathematics in the following way. The limit as x approaches C of f of x is equal to L. And so here is a function f of x where as x gets close to C, as x is getting close to the value C, here's x getting close to C, then f of x is getting close to the value L. So the input is getting close to C, but not necessarily actually C, and the output is getting close to L, the output of that function. And there's a little hole drawn in that function. It could be the case that f of C is actually equal to C, or it could be the case that f of C is actually equal to something else. So this is f of C. It could be the case that the limit as f of x approaches that value is equal to the function value at the point, or it could be the case that it is not. Let's take a look at a visual example and try to find the limits and the function values for a certain graph. So let's use the graph of g of x below to estimate the following values. And if that value is defined, you can just write DNE does not exist or undefined. So we're looking for g of negative 4, the limit as x approaches negative 4 of g of x, and so on. So pause and try that out for a minute, and then see how your answers align with the ones I'll go over in just a moment. Okay, so we've got g of negative 4. Well, open circles that are not filled in are going to stand for places where the function is not defined at that point. So there is no closed circle, there is no filled in point at the value x equals negative 4. There is no filled in value anywhere. So this value does not exist. How about the limit as x approaches negative 4 of g of x? Well, yes, as x gets close to negative 4 from either side, the function value is approaching one thing. So we are approaching one value. And what is that value? This is not incredibly precise, but let's just say it's 1.8. If you said 2, that's fine, 1.8, something like that. How about g of negative, how about g of negative 1? G of negative 1, g of -1, yes, that is defined. It looks like it's about -2. And that is also what the function is approaching as x approaches -1. So the limit as x approaches -1 of g of x is also -2. G of 1, well, g of 1 is defined. It's defined by that closed circle right there. So maybe that's like a 1.5. Notice that this open circle is not g of 1. The open circle means we are not defined at that point. What about the limit as x approaches 1 of g of x? So the definition of the limit is if the function approaches a single value as x gets close to the number 1 but is not necessarily equal to the number 1, then the limit exists. If the function does not approach a single value as x gets close to 1, then the limit does not exist. So in this case, as x approaches 1 from the right, we see, yeah, there's a limit, it's around 1.5. As x approaches -1 from the left, yes, there's a limit, maybe it's around -0.5, but there is no single value that g of x approaches as x goes to 1, so this limit does not exist. That limit does not exist. Later we'll look at right and left-hand limits, but the limit as x approaches 1, period, does not exist. Okay, g of 6, yes, g of 6 exists, and g of 6 is, again, wherever the function is filled in at that point. Looks like it's, maybe -1.8. And limit as x approaches 6 of g of x, well, that's what the function is actually doing. It doesn't matter what the point is actually doing, but the function itself, maybe it's approaching something like -3. So those are my solutions. This isn't a very precise graph, so it's okay if you're off by, a little bit. If you wrote like 2 here or -2.6 here or whatever, that's fine. It's just the general idea that I'm looking for.